Video, we're going to be talking about ratios and special right triangles. We have two that we're going to focus on. The first one is called a 45-45-90. It could go by a different name if we kind of analyze it a little bit. If we know that we have a right triangle where one of its acute angles is 45 degrees, that must mean that the other acute angle is 45 degrees. Those acute angles are going to add up to 90. They're complements. If those angles are the same, those angles are what are creating the length of each side, so that must mean that the side lengths are the same. So we have a triangle here that has two equal sides. That's known as isosceles. So this is an isosceles right triangle by a different name. However, we're going to refer to it as a 45-45-90 in reference to its angle measures. So here are the ratios that always apply to this type of triangle, and we can use Pythagorean theorem to prove this. If we know that two of the sides are the same length, and we say that each of them are x, then using the Pythagorean theorem, one side squared plus another side squared should equal the hypotenuse squared. We know that x squared plus x squared is 2x squared, and the hypotenuse squared we'll just call h squared. To solve for h, we're going to square root both sides. So that turns into the square root of 2x squared. And since we have a product here, we're allowed to break that up and take out any perfect squares. So we have x squared here. So let's take out an x, and that leaves behind the square root of 2. So there we can see that that's going to be our hypotenuse, always depending on if we have an isosceles triangle or not. So whatever the side length is, times the square root of 2 is going to be our hypotenuse length. So we'll be able to use that shortcut. What if we know the hypotenuse and we don't know the side or the leg here? Well, just to make it its most basic form, let's say that the hypotenuse is 1. And by doing that, we're actually going to get ready in pre-calculus to use some values on the unit circle, because it's going to turn out that the hypotenuse of the right triangle is going to be the radius of the circle. So if we can find our side lengths with a hypotenuse of 1, that's going to lead us right into the unit circle where we have a radius of 1, and we're going to see these side length measurements coming back. All right, so we know the sides are the same, so we're going to say x and x. So in the Pythagorean theorem, x squared plus x squared equals the hypotenuse squared. 1 squared is 1, and there are two x squareds here on the left side. To solve for x, or the side length, we're going to divide by 2 first. Keep that in your mind. We're going to take half of the hypotenuse, and then we're going to square root both sides to undo the square. So the side length is the square root of 1/2. We don't like to leave it in that form. That's not considered simplified, because we have a quotient under a square root, or any radical, allows us to rewrite that fraction given the top and the bottom that root. So we have the square root of 1 over the square root of 2. Square root of 1 is just 1. So now we're stuck with the square root of 2 in the denominator. Again, not considered simplified. We're going to do this step called rationalizing, where we make the denominator a rational number rather than an irrational number. In order to undo a square root, we end up just squaring it or multiplying it by itself. But we can't just do that to the bottom without doing it to the top. That's not balanced. So let's do the same thing to top and bottom here. Multiply by whatever the denominator is to undo our square root. So on top, we still have the square root of 2, but now on the bottom, squaring a square root undoes the root, and we're left with the number underneath. Or you could multiply this out. The square root of 2 times the square root of 2 is the square root of 4, which is 2. So now we have this simplified version of the square root of 1/2. It's the square root of 2 over 2. So notice that what we did is we took half of the hypotenuse, and we multiplied by the square root of 2. So that's going to be our shortcut if we want to solve for the leg given the hypotenuse. This value, the square root of 2 over 2, is going to be a length and a coordinate that happens on our unit circle. So remember that value corresponding with 45-degree angles. All right, let's practice solving for some side lengths using these two shortcuts. Here we're given the hypotenuse, so it's important to label the pieces that we know and label the pieces we don't know. So we're asked to find the unknown leg lengths or side lengths here. Well, given the hypotenuse, we know that we can just take half of the hypotenuse and multiply by the square root of 2. So half of 3 halves, and just stick the square root of 2 on the end of it there. X and Y are both congruent sides or congruent legs, so no further math to do there. You could prove all this using Pythagorean theorem if you wanted to, but it's much easier once you understand that it comes from Pythagorean theorem that you can just use these shortcuts. All right, in part B, this time we're given a leg value, and we're asked to find a hypotenuse and the other leg. Well, we know the other leg is going to be the exact same thing because it's an isosceles triangle and legs are congruent. So what's the hypotenuse? Well, up here we said if we just multiply the leg length by the square root of 2, we get the hypotenuse. So take 2 times the square root of 2 and then multiply it by another square root of 2. Squaring the square root of 2 just leaves 2. So the hypotenuse must be 2 times 2, which is 4. So you can always check your work. What's half of that times the square root of 2? That's the leg. So it works out. All right, for the next two, you can pause the video and try it on your own, and then check your work. All right, in part C, we're given the leg. So in order to find the hypotenuse, we're going to multiply by the square root of 2. So the square root of 6 times the square root of 2. Since they're both square roots, we're allowed to multiply them together under the radical. 6 times 2 gives us 12. So 2 times the square root of 12 is the length, but that's not, again, considered simplified because we can simplify by factoring this number 12 under the square root. In order to simplify square roots, we factor a number and try and use one of those factors as a perfect square. So we know that 4 times 3 is 12, and 4 is a perfect square, so we can simplify that and take it out of the radical. So the square root of 4 is 2. So now we have these two numbers multiplied at the front, 2 times 2, and the square root of 3 left behind. Y was the other leg, and we know that's going to be the same as the one that was given to us. In part D, we're given the hypotenuse, asked to find the leg, so we're going to cut the hypotenuse in half and attach the square root of 2 or multiply by the square root of 2. Sometimes that fraction that's created can be simplified, but in this case it can't. All right, so there's the 45, 45, 90. Let's take a look at the second special type of triangle called the 30, 60, 90 right triangle. And this 30, 60, 90 right triangle actually comes from an equilateral triangle, a triangle that has all equal sides, and therefore it must have all equal angles. If all the angles in a triangle are 180 degrees, then 3 equal angles would each be 60. If we bisect this equilateral triangle with a perpendicular bisector, then we split that 60 degrees in half up top, get 30 degrees. And we've created a right triangle because we bisected it with a perpendicular segment. So now we have this right triangle, this 30, 60, 90. Because each of the angles are different, that makes all the side lengths different. So this could also be known as a scalene right triangle. But there are different types of scalene right triangles. So that's not the most common way we'll refer to it. We'll call it the 30, 60, 90. In a 30, 60, 90, we have 3 different types of sides. Across from the right angle is still considered the hypotenuse. That's always true, and that's always the longest side in the right triangle. Across from the 30-degree angle, that 30-degree angle is smaller, so it's going to create a shorter side length over here that we're going to call the short leg, and just use SL to refer to that. The other angle, the 60-degree angle, is going to create a longer side, so we're going to call that the longer leg, and that's always across from the 60. So we'll shorten it to LL. So those are the 3 pieces we always need to identify, and if we can identify them, then here is how they relate to each other. The shorter leg, if you know that, is going to be half the hypotenuse, or double the short leg to get the hypotenuse. Also, if you have the short leg value, you can multiply by the square root of 3, and that will equal the longer leg's length. You can prove that that's true by, again, using the Pythagorean theorem. If I square this side and add the square of this side, it should equal the hypotenuse squared. X squared is going to be x squared. X times the square root of 3 squared. Well, the square root of 3 squared is 3, and x squared is x squared, so we have 3x squared there. 2x times 2x, or 2x squared, is 4x squared. And it is true that 1x squared plus 3x squared is 4x squared. So these ratios work out. Let's play around with it one more time here, and let's take it over. Think about our unit circle coming up. That unit circle is going to have a radius of 1, which means that the hypotenuse in our right triangle is going to be 1. So let's see what sort of side lengths we get if that is true. If I take half of my hypotenuse, I get my short leg. My short leg is across from the 30-degree angle. So half of 1 is 1/2. If I know my short leg, all I have to do is multiply by the square root of 3 to get my longer leg. So 1/2 times the square root of 3 is just the square root of 3 over 2. So again, these values right here are going to end up being coordinates on our unit circle. So know that they go with angles corresponding to 30 and 60 degrees. All right, so what did we just do? We said that the short leg was half the hypotenuse. We said that the short leg times the square root of 3 is the longer leg, and that the hypotenuse was just twice whatever the short leg was. So here are the 3 formulas that are most helpful. You can always start with these. You can develop your own if you play around with these formulas and solve for other pieces. For example, if you want to solve for the short leg and you're given the long leg, well, to do that you would just divide by the square root of 3. But then you would have to rationalize. So as it turns out, the short leg is 1/3 of the long leg times the square root of 3. So lots of different ways that you can use these formulas, but definitely know these ones to begin with. All right, let's practice. Given this right triangle, given 60-degree angle here, we know that the complement is going to be 30 degrees. Across from the 30-degree angle is the shorter leg, so we're given the shorter leg and we're asked to solve for the hypotenuse, which is always across from the hypotenuse. From the right angle, and the longer leg over here, which is always across from the 60-degree angle. All right, so since we have the short leg, it's kind of the easiest of the examples. Everything's based from the short leg. Let's double it to get the hypotenuse. Twice the short leg is the hypotenuse, so that's 16. And again, the short leg times the square root of 3 will give us the longer leg. So all we have to do is stick the square root of 3 onto 8 there. All right, part B, this is maybe one of the trickier ones, given the long leg. So we said that if we take the long leg and we divide it by the square root of 3, we should be able to get our short leg. So y is going to be our short leg, it's across from the 30. So let's take 2 times the square root of 3 and let's divide by the square root of 3. Well, that's just going to cancel the square root of 3 and we'll be left with 2. If the short leg is 2, the hypotenuse is just double that, so x is 4. All right, again, you can pause the video and work on the next 2 examples for yourself, and then check your work. In part C, we're given the hypotenuse across from the right angle. We're asked to find the short leg across from the 30 and the long leg across from the 60. All we have to do with the hypotenuse to get the short leg is cut it in half. So the short leg is 1, and then multiply your short leg by the square root of 3 to get your longer leg. In part D, it gets a little trickier when those side lengths are a little bit more complicated. This one tends to work out pretty nicely here. If I take what's given to me as the long leg across from the 60-degree angle, and I divide it by the square root of 3, I'll be able to get the short leg. So that'll cancel the square root of 3. Dividing by the square root of 3 is the same as multiplying by 1 over the square root of 3. So that's what I wrote there. So that cancels. We're left with 3 over 2, or 1.5. Now that we have the short leg, all we got to do is double it, or multiply by 2, and And that'll cancel that division of 2, leaving us 3 as the length of the hypotenuse. All right, so keep practicing those. Definitely know these relationships. And take a moment every once in a while to study what if the what if the hypotenuse is 1 in this example, giving us these lengths, which will become coordinates, and these lengths, which will become coordinates. You'll see them happening next week when we talk about the unit circle, and hopefully they'll be familiar.